Hi, it's Mr. Kane here, and yes, as it says, we're going to meet the metals in this video clip. We're going to learn what sort of properties that they have and some things about them. So on the screen here we've got a whole selection of metals. Some of them are pure metal. For example, we've got aluminium, that's just only aluminium. Cast iron is only iron. Copper is just copper. But there are some others on here, for example steel, bronze, brass, that are what we call alloys. And by the time we finish learning about metals, you should know what an alloy is and why we use them. But let's go and meet the metals and their major properties. So luster, it's a fancy word. What it means is that it's shiny. So silver, gold, when you think of those metals you think they're nice and bright and shiny. And in fact all metals are shiny, although some you will need to dig away at them a bit. So for example, over here on the screen we've got, this is sodium. It's a very soft metal, you can cut it with a knife. The outside often has an oxidized coating on it, which is quite dark, but when you cut it with a knife, the end of it is very shiny. Another one over here, in this other corner here, this is potassium, and it's inside a glass container because it's very reactive. It'll actually react with air. So it's shiny in there, but if we let it out into the air, then it would actually catch fire. It's that reactive. So metals are shiny. What else we got? Malleability. Another big word, maybe it's new to you. Basically it means you can pound it into shape. You can hit it and change its shape. Often though we'll heat it till it's red hot, make it a bit softer and pound things into shape. Think of the blacksmiths making horseshoes for horses. Today it often is all sort of mechanized, but back in the day I think my great uncle used to be a blacksmith and was making horseshoes. Conductivity. So what does that mean for, we think of electricity, and wires are made of metal, in particular copper metal, which is very good at conducting. It's also very easily able to be changed its shape, bent around corners and stuff. Here we've got some wires, they're surrounded in a plastic coating. That's to insulate them so the electricity flows down the wires and doesn't escape to where you don't want it to be. So we add an energy source, in this case the AA battery. We've got light bulb in there, and if we were to make the connection across here between this A and B, connect there too, then the light bulb will start to glow, because electricity will flow through the wires. Conductivity again, it's not just to do with electricity, but heat. Metals are very good at conducting heat. So often we'll have pots that are made of layers of metal that are designed to conduct the heat from the stove top into the whatever's being cooked in the pot. And you'll find often that the handle is made of a material that doesn't conduct. We've got some pots at home with wooden handles, some with a plastic coating that doesn't conduct. We do also have some like this one and this one. You actually have a metal handle, but it's built in such a way to lessen the conductivity of the heat. What else we've got? Ductility, another new word I think. It means you can draw it out into a wire, you can stretch it out, and there's copper wire, so that's commonly done. We have a small farm where we live, and we've got lots of fencing wires being pulled. That's all been pulled out into wires on coils, and we turn them into fences. So you can pull it and stretch it into a wire. Here's an example of something that's been stretched, and you can sort of see this one wasn't super ductile because it started to stretch. You can sort of see how it's curled in here, but at the end here you can see where it's actually broken off. Here it's nice and shiny, but here you can see where it's tapered in. The shine has sort of gone a little bit because it's all being stretched out. So ductility means you can stretch it out. State. What state are you going to find metals in? Well, they're going to be solid. All metals, apart from two, are solid at room temperature. Of course you can heat them up and melt them if you wish, but they're all going to be solid at room temperature, apart from mercury, and that's was used in thermometers and all sorts of places and barometers because of its liquid state at room temperature, but we discovered that mercury gives off vapour, which is actually toxic and poisonous. So in applications where we need to use a liquid metal, we're actually using a newer one called gallium. And gallium melts in your palm of your hand. When it's kept cold it will be solid, but room temperature it will be liquid. That's gallium. But basically metals are solid apart from those two. So let's summarise. So here's our periodic table. Metals, they've got extra electrons. That means the outside shell, their valence shell, has only a few electrons in it, and they like to get rid of them, which is what makes them very good conductors. So conductive of heat and electricity. Malleability, you can pound them into shape. So electricity there, pound it into shape there. They're also dense and solid. We use them for coins and things so that they don't wear out in a hurry. They're shiny and ductile, you can pull it out into wires, and you'll find the metals all on the left hand side of the periodic table. In fact, the bulk of the elements on the periodic table are metals. So hopefully that's been a good introduction to metals. You've learned something new and learned some new words and what they mean, and now know what things to look out for when you're looking for a metal. Hope that was helpful.